All right. So the question is, if we look at the orange, there's these two masses there on different slopes, but they're joined together by a rope or something, and they're heading to the right. So they're going. So this mass is heading this way. So the tension in the rope is always the same to both. But the result is that they're both traveling that way with an acceleration of a. So if we talk about force, remember force is mass times acceleration. So the result, if we just look at one mass at a time, what's winning in this one is the tension that's heading up the rope, whereas the mass or the force due to gravity is heading down the slope. So the tension is winning here. But I think your question was just to break up and find the mg sine theta. I'll show you what you do. So with each of the masses, if you always put the normal force in, so normal against, so this would be the normal force, the normal direction. And then if you, so if you think of this, it's exactly 90 degrees to the slope, and then put the slope in as well. So that's your 90 degree there. And then if I go straight down, I've now got my, the gravitational direction as well. So if I did that over here as well, I'd put, so I always put the normal in, well, this is what I should do, and the slope in, so the normal to the slope, then the slope, and then directly down, so the vertical. When I do that, you can see, I'll go back to the blue, this angle here will always be theta. Why? Because, let me do a different color, this is 90 degrees, so this angle here will be 90 take away theta, and this whole angle here is 90 degrees, so that little angle has to be theta. Okay, so again, over here, that little top angle in the green is also going to be 2 theta. Okay, so back to the blue. So the vertical force downwards is always mass times gravity. So in this case, it will be 3 times gravity, 3g. If I break that up, excuse me, I just drew it over here. So that's 3g on the hypotenuse, and that's theta. So if you just use trig on that diagram, so let's call this x and y. No, let's call it something different. Let's call it c and d. For example, if I do sine theta, I'm going to get c, so opposite over hypotenuse. So that c is going to be 3g sine theta. Okay, so that's going to be 3g sine theta. And then you could do the same with d, and you'd get 3g cos theta. So I usually just go, like if I'm looking at the green one here, I'd be going, okay, oops, where's my 90 degree? It's over here, and there's my 2 theta. So I go, and I know this is 2g because it's mass times gravity going down. So straight away I know this is this is using opposite and hypotenuse. So I know this is sine 2 theta of that 2g. It's a proportion of that 2g, and this would be using my my a and my h. So therefore that's cos. So this will be cos of the angle, that proportion of my 2g. All right, hope that helps.